So, because you need a graphing calculator today, and because the majority of you are using our calculators and you don't know who did what on them beforehand, if you have your own, don't follow these steps. But if you have one of ours, you're going to turn your calculator on, obviously, and then you're going to hit the on key again. That's going to get you into this screen, okay? And from there, you want to go to a new document. And no, you don't want to save it, the old one. Okay? So you want to hit a new document, because then now it's fresh, clean, in all your stuff. You've done it. Okay? Now, if you are using your own calculator, if you want to clear everything out, do that. But if you don't want to clear everything out, you can just continue on from where it is. We're going to be dealing with graphs today. So you're going to want to open up a graphing page. Okay? So because we're going to be flippity-floppeting back and forth, I got the screen set up like this, so I apologize for how small it is. But if you do what I'm doing, you should be able to just hold in your hand what you have. Okay? So, using the graphing calculators, we want to graph this function. Okay? Well, we're graphing a parametric function, so I need to go to the graphing calculator, and I need to go into Menu, and I'm going to go into number 3, Graph Entry or Edit. Okay? Because right now I'm in function form, but I want to graph a parametric function, so I need to switch that to a parametric function. Now it becomes the format that I need to type in looks exactly like my problem. Okay? So the first thing I'm going to type in is I'm going to type in 3, and I'm going to type in cosine. Now cosine, I can either type it in, or I can go into trig and just select cosine. I can do either or. Okay? But do I want theta? I want t, because that's the variable that I am. And I want to put that in a set of parentheses. Okay? Now I can go down, or I can hit tab. Takes me to the y's. There I'm going to type in 3. And again, I could either type in sine, S-I-N, or I could go here into trig and pick sine, and I want sine of t. Okay? I want to go from 0 to 2 pi. Again, you need to look up in the upper right-hand corner of your calculator. If it is in RAD, then you're going to go from 0 to 2 pi. If it is in DEG, you're going to go from 0 to 360, because we want to make a complete loop around the unit circle. Okay? So dependent upon which one you're in, there's that, and 0.13 is pi over 24. Okay? But if you wanted to switch those, you could highlight those, and you could go to pi, and here you could go pi, or you can even type in the word pi divided by 24. Then when I hit enter, I get that. What geometric figure is that? Circle. Right? I get a circle. Because if I think about it, well, it's a circle. Give me a couple more details about said circle. Center at the origin, what's 3 units? The radius is 3 units. Okay? So I've got a circle centered at the origin with a radius of 3 units. Okay? Because if I think about it, my x, the point that I plot, x comma y, is 3 cosine comma 3 sine. So if I wanted to make this be the unit circle, what would I change? Take out the 3 and just make it a, or 1. Yeah, I make it a 1 because I want a radius of 1. If I want a radius of 10, what do I change? 3 to 10. Okay? All right? Fantastic. So in this function, this is a circle. Radius of 3 and a center at the origin. All right, fantastic. Love every bit of that. Okay. Next thing I want to talk about is let's change our t values. Let's not go from 0 to 2 pi. Let's adjust those a little bit. So let's adjust the t values and figure out what happens to it. Okay? So if I gotta get back over on this side, and I go tab, and I go up, and if I go from 0 to, I'm going to say 100, anything change? Nothing really changed, did it? Okay, so nothing changed there. Let's go from, instead of 100, let's go something smaller than 2 pi now. Let's go just pi. Row. What happened? I took out some of the range, so I took out some of the circle, right? So it's only going to go over to pi. So it's only going to be the top half of the circle. It's the whole rounding. It only, because it goes to 3.14, it doesn't go to exact, and it's funky. Okay. What if I wanted the left half of the circle? And left half of the circle. Oh yeah, if I went just the left quadrant, yeah. So pi over 2 to pi. Yeah. Okay. What if, here's crazy talk, what if I wanted the right half of the circle? What if I want the right half of the circle? Negative pi over 2 to pi over 2, right? Okay. So the t values control what part of the function or part of the graph that I see. So our t values control what part of the graph we see. All right? Now, let's go back to 0 to 2 pi. There we go. Okay. So I'm back to 0 to 2 pi, and now I want to adjust the t-step value on our graph. Right now, we have a t-step at 0.5. What if I adjusted it to a t-step of 2? It's jagged, right? And then it's just like, I'm done. Draws a line back to the start, right? about a t-step of 0.2? Gives me a nice smooth curve. Yeah. What about a t-step of 100 makes it go away. Okay, so what about 4? Just a line. Okay? What the t-step is doing, or what the t-step does, is it is how many times the calculator calculates the values. So if you think about yesterday when we were doing these by hand, our t-step yesterday was 1. We calculated it, we started it at the first number, then we went to all the integers up until the end. So our t-step yesterday was 1. We calculated the value of the function at t values that differed by 1. And then we just filled in because we were smart enough to fill it in. Okay? Well, your calculator only does what it tells you to do. So if you tell it to calculate this at 4, if you have a t-step of 4, it's going to start at 0. Right here is 0. It's going to start at 0, and it's going to calculate the value, and it's going to give it to you. Then it's going to go 4 more away. So in this case, that's 4 radians away is what it's going to do. And it's going to calculate it here. At t equals 4. Then it's going to go 4 more radians, but if it goes 4 more radians, that's outside the range. So it's got nothing else to calculate. So it only calculated 2 points, and it's got to connect them, because it's a function. So it connects those 2 points. Okay? If the smaller your t-step is, the smoother your curve is. Okay? If it's a curve. Or the more times that the calculator will actually calculate those things. Okay? Fantastic. So, graph this one for me. Okay? It's an ellipse, but I want you to figure out where the center is of the ellipse. So my x value is 3 cosine of t plus 1. My y value is 2 sine of t minus 2. Again, I can't use theta here because my function is based off of t. And then I'm going from 0 to 2 pi, and my t-step is 0.13. When I hit enter, I get, oops, gotta go over here. When I hit enter, I get that. From our conic section unit, the center of an ellipse is at the intersection of the minor axes and the major axes. So that gives me an intersection point of right there, which to me looks to be at what? 1 comma negative 2? Positive 1 comma negative 2. Where did those show up earlier? Right here. Okay. Positive 1 is right there. And negative 2 is right there. And then the stretchiness, it's elongated on the x, so the major is the x-axis, or the horizontal axis is the major axis. Good times. Good times. What I would like you to do now is I would like you to graph it. And then I want you to eliminate the parameter by hand on it. All right, so there it is. Okay. It goes on a while yet. Okay. But it goes on. One thing that I want to teach you before we eliminate the parameter by hand is I want to teach you all about the trace, because we're going to need to know trace coming up here. Okay? So if I go over here into menu and I select trace, okay, I'm going to set my trace step, and I want my trace step to be 1. I want to be like yesterday. I want to fill in my chart. Okay? So I want my trace step to be 1. So I hit trace step of 1, I hit OK, I go back into menu, I go into trace, and I hit graph trace. Now, what that's going to do is as I scroll left and right, it's going to always go up by a t-value or down by a t-value of 1. And then when I get to the end, if I hit to the, in this case, to the left one more, it puts me back up. Okay? All right? So it goes, and then I can keep going down like that. And so I can, if my t-value here is 1, then that gives me an x value of negative 1 and a y value of positive 1/2. And I can fill in my chart much more quickly. T-value of 2 gets me at 3, 1. And I can go negative on it also. T-value of 0 gets me 1 for my x, 0 for my y, and so on and so forth. Okay? Okay? So it tells me, or if I wanted to go by a half, or if I wanted to go by a tenth, I could trace by whatever I want there. Okay? So now let's eliminate the parameter here by hand. Okay? Can move this over a little bit for right now. Make that be a little bit bigger for us. Give me a little extra color choices down there. Okay, so I'm going to pick y equals 1/2 t to eliminate the parameter with. Okay? Because I can multiply both sides of that by 2, giving me 2y is equal to t. Then I'm going to take my x value, x equals t cubed minus 3t plus 1, and I'm going to substitute in 2y in place of t. And that gives me x here equals 8y cubed minus 6y plus 1. I were to graph that function on my chart, it would go right over the top of the blue one. Okay? What figure is this? If I graph this, what is it? Be more specific. Circle with a radius of 5. Centered at the origin. Okay? Right? Circle with a radius of 5, centered at the origin. Now, first semester we talked about conic sections. What was the conic section equation for a circle with radius 5 and centered at the origin? Anybody remember? What's the equation for a circle centered at the origin with radius of 5? X squared plus y squared equals 25. That's what I want to get to. Okay? That's what I want to get to. What I want you to do now is I want you to eliminate the parameter and get me x squared plus y squared equals 25. I'm guessing we hit a roadblock. Definitely hit a roadblock. Okay? So somebody tell me what they did first. Okay, which one did you choose? The y? Okay, so you went with y equals 5 sine of theta, right? And you divided first by 5. Right? And what? Inverse sine of that. And then plug that into the other one. And then you said, I'm out. Seacrest out. Right? Because guess what? That's not going to get me to x squared plus y squared equals 25. Okay? So I can't use that. Oh, man. Shucky darn. Crepes all Friday. So what other tools do we have in our toolbox that use sine and cosine? We got the hammer, right? What's the hammer? So we've got the hammer, which is cosine squared of theta plus sine squared of theta is equal to 1, right? So what if I took x equals 5 cosine of theta and I said x over 5 equals the cosine of theta? Would that be legal? And what if I took y equals 5 sine of theta, and I divided by 5, and I said that's y divided by 5 equals the sine of theta. So I could go over here, and then I could say that this is x over 5 quantity squared plus y over 5 quantity squared equaling 1. This gets me x squared over 25. This gets me y squared over 25. Can I clear up those fractions? Multiply everything by 25. X squared plus y squared equals 25. And that, from our first semester conic section, is a circle centered at the origin with a radius of 5, which is exactly how we described it up here and how we wrote it out as what we were supposed to get. Okay? Great place to end on the day.